Alright, the first thing you're going to do is you're going to turn on the multimeter. So this one has a dial. The upward direction is off. If you have some of the other ones, they have a little switch down here. Whichever you have, make sure you turn it off when you're done to save those batteries. You're going to turn to this region right here that says DC voltage. Okay, and you'll see 5 different numbers here. Those are basically ranges that you are going to decide on based on the size or the amount of voltage you're measuring. So like different amounts of sensitivity. We want this very middle one here, the 20. Okay, everything we're measuring will be in that range. So go ahead and turn it to there. Okay, then you have these two probes here, and what I want you to do is take the 2 probes and touch them to either end of the battery to see what the voltage is. Okay, and then test it for the other one too. Alright, once you're done with that, take both batteries and put them in here. And measure the voltage across both the batteries together by touching the ends of these to the ends of the wires that are exposed. Alright, once you've done that, see if that voltage you got here, how it compares to the previous ones you've got. Okay, so now that we've done that, I want you to build a simple circuit. Okay, we're going to have in our circuit the battery supply. Okay, we're going to connect it to a single bulb and a switch. Okay, so go ahead and build this circuit, and once you do, I want you, when the switch is open, or closed rather, so that the circuit can flow, I want you to measure the voltage across here and across here on the battery. Okay, and tell me what you find out. Okay, so the next thing I want you to do is we're going to build another circuit that has 2 light bulbs. Okay, and it's going to turn out that when you build a circuit, you can actually arrange the light bulbs in 2 different ways. Okay, the first way that we can do it, okay, we'll call this series. And in a series circuit, the light bulbs are actually in a series with each other. Go ahead and add a switch in here too. Okay, so go ahead and build this circuit here. Have one light bulb after the next light bulb, going back through the switch, and again you're going to measure voltage here, and then you'll measure it here and here. I want you to also, once you measure these ones, add them together and compare it to this one. When you're making a series circuit, what this is going to look like is you'll have these 2 bulbs right here connected with one wire in between them. Alright, we're going to make another light bulb circuit this time, but this one, instead of being in series, will be in parallel. Okay, here's what that will look like. There's a couple ways we can draw it. We can draw it like this. Okay, and we'll put a switch right here, or we can draw it like this. Okay, where the current splits, or the wire split off to go between the 2 bulbs, comes back together and goes back around. So these are 2 different ways of drawing actually the same circuit. Okay, a hint for when you're making a parallel circuit. Okay, the current is going to flow out of the battery, so we'll connect a wire to the battery, and then right here and right here, those places represent a split, which means the wire has to split into 2 wires. So what you can do is you can take 2 wires and connect both of them to right here. Okay, and then connect one to each of the bulbs, and then on the other side bring them back together. The other option we have is this. I can just connect both of the bulbs at the same time right here. Okay, like this. And then I could do the same thing on the other side. Okay, so this represents right here 2 bulbs in parallel, because what's happening is the circuit is branching, splitting, and then coming back together. So go ahead and build your parallel circuit. Okay, and again, I want you to measure voltage across each bulb and compare them back to the original one. So as we're going, you might start to be making some observations. And one of the things you might notice is that the voltages from all the components, like say in this circuit right here, if you have two bulbs, okay, the voltages across these two bulbs should add to be the same as what was across this battery. Okay, and there's a reason for that. Okay, sometimes it's helpful to think of electricity like water. Okay, so imagine I have a tall cliff or mountain right here, and I take water and I lift it up to the top. Okay, and I dump it in a little slide. Okay, and it's going to slide its way back to the bottom, where something is taking it and lifting it back to the top. This place where we're lifting it up to the top, we call this the voltage. Okay, then as the water's flowing back down, we would refer to the speed at which it flows down as the current. Okay, now I want you to think of what things might slow water down. Okay, is there any way that we can make it so the water's coming down to the bottom more slowly? Maybe you can make the path a little bit narrower. Okay, so let's say that there's a channel for the water to flow through like this. Okay, and let's say that in a couple places I squeeze it close together, okay, to slow it down. Alright, and maybe I'll do it again right here. Okay, these are places that cause the water to slow down, and the more of these that we put in, the slower the water will be moving. Okay, we could think of this the same way with electricity. The more light bulbs that we put in, or the more objects with resistance, the slower the current moves through the circuit. Okay, you can also think of places like this as places where power is being consumed. Okay, and so like in the sense of the water, you know, the water might be passing through like a water wheel, which is actually used to generate electricity, and that would be what's slowing the water down. In the case of a light bulb, what's happening is there's a little piece of filament in here, a little piece of metal that the electrons are actually heating up, and that's what's slowing them down here. But what's important is that across each of these, the water is going to fall some amount of distance. We'll call this D1, and this distance D2. When we come back to here, we have to raise them back up that whole entire distance. Okay? And so this is an example of a series circuit. Okay, the more things that we put in the way, the slower it's going to be traveling. Okay, then so for a parallel circuit, I'll show one more example like that. We have the same kind of thing. Water is kind of lifted up to the top of a hill, and then this time as it flows down, maybe the path branches off and it can go two different ways. Okay, well, a river that branches in two places, it has more places for the water to flow, which means the current can flow faster and the water can flow faster in this river than the previous one. Okay, and in a parallel circuit, you have more places for the current to travel through, and the more you add on, the more places you have, and so more electricity can flow. Okay, and so even though you're adding in places to slow the electricity on that circuit, you're also giving it more paths to take, so it's allowed to go faster. Okay, now the benefit to a circuit like this, let's say that something happens to this light bulb, okay, and it goes out and doesn't allow electricity to flow anymore. These three can still work and still allow the current to flow. If it was a series circuit and one of the bulbs went out, the electricity would be trapped and the circuit would go out. Okay, so here's our series circuit. We get rid of one of those and the circuit doesn't work anymore. Alright, I want you to think it right now for a minute. Which of these would be in your house? Which type of circuit is in your house?